All right, let's do our first one. Well, the first six, what we know is that triangle BIG, so it really doesn't matter which way you put the letter. Sometimes people use counterclockwise or sometimes clockwise. So if we use clockwise, we got B here, I here, G here. And the other one, we're going to follow, since we did this way for the first one, we have to follow that in the same direction. So C, B is corresponding to C, and I is corresponding to A, and G is corresponding to T. Okay, so we know those two are congruent. Now we just need to fill the blank. So number one, angle A is congruent to which angle? Hello, Grayson? Okay, very good. Number two, what is equal to the measure of A? So when we're talking about measure, we're talking about, in this case, talking about degrees. So which two angles have the same degree? Well, the answer for measure of A, actually, we know A is corresponding to I. So we know those two have the same measure. Well, there's two ways to write it. One way is to write it as a congruency. This is a kind of talk about their geometrical the uh, geometrical properties. So basically, this angle is congruent to this angle. That's the one. But here we're talking about the measurement. So that's why we use equal sign. So measure A has to equal to measure of I. So whatever, if this one is 45, then A will be 45. So they are the same. Okay, are we good on this one? All right. Okay. Number three, BI. BI means the line segment. Uh, the actually without anything, just BI itself, it means the length from B to I. There is, we can also, when we write BI this, that means a line segment, just B and I as a geometric object. Sometimes we can write BI like this. That means a line, which actually a line goes through B and I. So that's a difference between uh, three different ways of writing it. But here we write BI, that means that is the length of this line segment. Uh, Basically, what's the measure of the line segment? Okay, doing number three. Okay, very good. It is CA. Good job. Number four. Now we're talking about line segment. That's why we use the congruency symbol. So make sure you follow the sequence. Okay, we talk about AT. AT is from here to here. So therefore, we're going to use IG. Okay, so the vertices, the points, has to line up. So this actually is IG, and put the bar over. Okay, good on that. Okay, number five, triangle IGB is congruent to triangle what? Okay, I very good. Is A, T, and C. Good job. Okay, number six. What is congruent to triangle CAT? Perfect. All right, let's do number seven. If triangle ADEF is congruent to triangle RST, the measure of D is equal to 100 and measure of F, the angle F is 40 degree. They want you to give four congruent angles.
Wait, on question seven?
Yeah, yeah. Basically, which angle is congruent to which angle? So what we got here, if you go and graph it, we got two. So we got D, E, F, and actually should just uh, R, S, T. So should have basically actually not four, three. So we know that angle R is congruent to angle D. Then angle S is congruent to angle E. Then angle T is congruent to angle F. Good. Yeah, very good on that. Okay. Assume that triangle LXR is congruent to F and E. List six congruent part. Basically, three congruent angles and three congruent sides. You got LXR, and other one is F and E. Hello.
Hi, sorry it kicked me out.
That's all right.
Let's see.
Okay, we're doing problem 8. Hello?
Yes.
Good? Yeah, we're doing problem 8. Oh, there's another one. So Rx to Fn, very good. Rx is to Nz. So make, yeah, XR is NZ, very good. LR is FE, good job. LFX to N, perfect. Okay, uh, number 9. In the following figure, two triangles are congruent. Fill the blanks to prove that the line segment ST is parallel to line segment RK. Okay, first of all, triangle STO is congruent to what?
STO.
Yeah, yeah, triangle STO is congruent to what? Well, actually, there is a missing some information. Actually, we should add something. We know SO is congruent to KO. Okay. So this is congruent to this, and also TO is congruent to KO. That's missing. Oh, sorry. RO. So this side is congruent to this side. Good. Yeah, and that should be there. So KOR, very, very good. KOR. So the reason is what? Think about when we prove congruent, two triangle congruent, we have SSS, we have SAS, we have ASA, we have AAS. Good. So we want to see which one is based on.
Yeah.
Well, this actually, you can see that we got two sides. This side congruent to that side, and this side congruent to that side. And the angle between those two sides, this angle and that angle, they are vertical angles. And we know that vertical angle are always congruent. So therefore, we are using side angle side. So this will be side angle side. Good. Uh, Grayson, we good here? Okay. So we look to B. Angle S is congruent to which angle because of what? No, it's not because of that. When we use SAS, we're trying to prove the congruency of two triangles. So we already used that. So angle S actually is congruent to angle K, this one. Angle S is congruent angle K. Triangle angle S is congruent angle K. And this is because something we called congruent part of a congruent triangle is congruent. So because we have a triangle congruent, S is part of the S and K is part of the congruent triangles. So we know that congruent parts of congruent triangles are congruent. So we write as CPCTC, congruent parts. So congruent parts of congruent triangles are congruent. So that's the CPCTC means. Okay, are we good on that? All right, let's do C. SO is congruent to what? Because, very good. So SO actually congruent to SO is congruent to KO. So that's KO because CPCTC. So therefore, O is the middle point of SK. Yeah, because this is congruent to that. So therefore, O is the middle point. Okay, we good? Okay, now let's do D. Okay. Okay, T is congruent to R, and the reason is because what's the reason? Yeah, so C is actually called corresponding parts because this is not side, this is angle. So a general term, parts includes both sides and angles. So we use that. So CP, CTC. We just use that to do it. Okay. And therefore, ST is parallel to RF because of what? So it has to do with T and R angle because angle T is congruent to angle R. So therefore, we say this line is parallel to this line. But there's a reason for that. There is a theorem behind that we need to use. So what's that theorem? Grayson?
Sorry, where's F on here?
What's that?
Where's F on here?
F. What do you mean F?
It says hence ST and RF.
Oh, RK, sorry.
Oh, okay, I was confused.
Yeah, sorry about that. That should be RK. Yep, alternate interior angles uh, are congruent. Yep, because of that. Very good. Okay. Uh, all right, we got last one here. In the following figure, two triangles are congruent. Fill the blanks. Two triangles. Basically, we're talking about triangle LPA is congruent to triangle uh, A R A R L. So LPAARL. Okay. So the first one, triangle PAL is congruent to triangle this one. So we're talking about the same triangle, but we just rearrange the letters, but make sure they still uh the letters are still corresponding to each other. Yeah. So PAL, which is R, well, so PAL is this, PAL. And if you see that the P is corresponding to P, oh, sorry, R. Okay. So that is R. A is corresponding to L. So R, L, and A. Good. Okay. B, the line segment PA is congruent to line segment of what?
Sorry, number B.
Number, yeah, B. Uh, PA is congruent to what? Is R. So P corresponding to R. So we write that as R. A is corresponding to L. So like that. Okay. Okay. C. Angle one is congruent to angle uh which one and because of what?
Sorry, which one is number one?
Uh C. Angle one is
There it
corresponding to
is.
what? Yeah. Okay, so one is congruent to this angle, actually is congruent to this angle. And because what?
because.
No, they are not corresponding angles. Corresponding angle is talking about this. We got two lines, we got transversal. This angle is, and that angle are called corresponding angles. So the reason for these two are congruent is because the top triangle is congruent bottom triangle. So this is the, we call C, congruent parts of congruent triangles are congruent, CPCTC. Now, therefore, PA, which is the top line, is parallel to what line? So PA here is parallel to what? And because, well, PA is this line, and because we know this angle is congruent to that angle, and we say that PA is congruent to LR, and the reason for that is, so what's the reason? Well, we're not, it's, you got the alternate interior angles are right, but they are not corresponding. They are congruent, okay? So this angle and this angle are called alternate interior angles. And we already showed that they are congruent because they are part of the congruent triangle. So, but if the alternate interior angles are congruent, Then we know that we have this theorem about alternate interior angles. So when the alternate interior angles are congruent, the two lines here, this line and that line, are congruent. So that is because the alternate interior angles are congruent, not corresponding. Okay. All right. So let's do the second one. Angle 2 is congruent to angle what because of what, and therefore what is parallel to what and because of what. Okay. Okay. What do you mean by IRA? Well, angle, we're talking about angles. So angle 2 is congruent to which angle? We're talking about this angle.
Oh, sorry.
This angle is congruent to. Okay, well, first of all, angle 2 is congruent to angle 4, okay? This is angle 4. And because this is part of the uh, corresponding parts of the congruent triangle. So it's CP, CTC. Therefore, we know LP, this angle, which is this line, is parallel to this line, which is AR. And that because, of course, it's alternate interior angles are congruent. Good. Okay. All right. So this is what we have for today. I'll see you next week. Okay.
Yeah.
All right. Bye.